Streaming platform. Run away!
All right. That's a lot. Too much. All right. So everything is looking good. Let me go to my book real quick. I lost it. Here it is. Okay. We're gonna do quickly just a quick live stream, about an hour of a live stream. We're going to do chapter 15 today, which is let me get the title real quick. Managing the Linux kernel and loadable kernel modules. All right, so let's get into it. Really, there's no other way around it. I had a short stream yesterday, and that wasn't fun. It wasn't a good one, so I had to delete it. But yeah, again, we're doing chapter 15, and hold on, let me clear this thing. Yeah, what's this? Oh no, how do I? All right, you know what? I'm just gonna do that. I'm just gonna do that. Let's do Control and T. All right, so I'm gonna do another one of this and set one over here and set this one over here so that I could do that. Oh no, not that. So that I could easily alt, make it much more easier. Can I do Control Alt? Okay, no. All right, let's start with the reading, and then we're going to do this. All right, so all operating systems are made up of at least two major components. The first and most important of these is the kernel. The kernel is at the center of the operating system and controls everything the operating system does, including managing memory, controlling the CPU, and even controlling what the user sees on the screen. The second element of the operating system is often referred to as user land and includes nearly everything else. The kernel is designed to be a protected or privileged area that can only be accessed by roots or other privileged accounts. This is for good reason, as access to the kernel can provide nearly unfettered access to the operating system. As a result, most operating systems provide users and services access only to user land, where the user can access nearly anything they need without taking control of the operating system. I guess that's the land where we are. All right. Access to the kernel allows the user to change how the operating system works, looks, and feels. It also allowed them to crash the operating system, making it unworkable. Despite this risk, in some cases, the system admin must very carefully access the kernel for operational and security reasons. In this chapter, we'll examine how to alter the way the kernel works and add new modules to the kernel. It probably goes without saying that if a hacker can alter the target's kernel, they can control the system. Furthermore, the attacker may need to alter how the kernel functions for some attacks, such as man in the middle, aka MITM attack, where the hacker places themselves between the client and the server and can eavesdrop on or alter the communication first. First, we'll take a closer look at the kernel structure and its modules. Okay. All right. What is the kernel module? All right. So the kernel is the central nerve system of our operating system, controlling everything it does, including managing interactions between hardware components and starting the necessary services. The kernel operates between the user applications you see and the hardware that runs everything, like the CPU, memory, and hardware. Linux is a monolithic kernel that enables the addition of kernel modules. As such, modules can be added and removed from the kernel. The kernel will occasionally need updating, which might entail installing new device drivers, such as a video card, Bluetooth devices, or USB devices, file system drivers, and even systems extension. These drivers must be embedded in the kernel to be fully functional. In some systems, it adds to add a driver, you have to rebuild, compile, and reboot the entire kernel. But Linux has the capability of adding some modules to the kernel without going through the entire process. These modules are referred to as loadable kernel modules, or LKMs. Okay, let's take some quick notes about kernels. So, oh, that's different. Okay, so on here we can have let's travel to the documents real quick. You know what I'm saying? Let me make it like here. Let's see, notes. Okay, so let's go into notes, and then let's add let's see, kernel kernel dot txt. Okay, so basic, it's so kernel uses modules. You can add and remove modules on kernel. Can you add and remove modules on kernel? Oops, I can't do that. That's why I do not like. Okay, let's just go to nano. Okay. All right. Okay, so you can add and remove modules. It is between the user and the hardware. It is the most important. Component. Okay. Bulletproof, bullet or whatever. These modules are referred to loadable. Adding modules and removing them is a process called loadable kernel modules, or LKMs. Okay. LKMs have access to the lower level of the kernel by necessity, making them an incredibly vulnerable target for hackers. A particular type of malware known as a rootkit embeds itself into the kernel of the operating system, often through these LKMs. If malware embedded itself in the kernel, the hacker can take complete control of the operating system. Okay, so rootkit is a type of malware that embeds itself in the kernel through LKMs. They are they vulnerable? Making them incredibly, they are vulnerable. Okay. KLMs, okay, or KLMs. They are vulnerable. Alright. So got some notes, and let's just write up. All right. If a hacker can get the Linux admin to load a new module to the kernel, the hacker not only can gain control over the target system, but because they are operating on the kernel level of the operating system, can control what the target system is reporting in terms of processes, port services, hard drive space, and almost anything else you can think of. Oof, man. And a hacker has access to the kernel. It basically have access to everything and can do anything. Okay. You can do anything. This is alright. So if a hacker has resolved attempt a Linux admin into installing a video or other devices driver that has a rootkit embedded in it, the hacker yeah, okay. So again, this is a way for some the most ambitious rootkits to take advantage of Linux. Okay, so with rootkits, a hacker has to kind of like convince an admin into installing a video or other device driver that has a rootkit embedded in it. The hacker can take control of the system and kernel. Understanding LKMs is absolutely key to being an effective Linux admin and being a very effective stealthy hacker. Yeah, let's take a look at how the kernel can manage for good and ill. My gosh, that's a lot. Checking the kernel version. Okay, so the first step to understanding the kernel is to check what kernel your system is running. There are at least two ways to do this. First, you can enter the following. Let's do that. I'm going to use this as a screen. So we can do uname -a. And that's the version of our kernel. All right. The kernel responds by telling us the distribution our OS is running is Linux Kali. The kernel build is 4.64 and the architecture is built for the x86-84 architecture. All right. It also tells us the symmetric multiprocessing capabilities. CMP preempts dynamic Kali and was built with kernel version 4.19 on January 3rd, 2019. Mine is 2025 September. Okay, your output may be different depending on which kernel you're using build. How to get out that out now. All right, build install. This information can be required when you install it or load kernel driver, so it's useful to understand how to get it. On other ways to get this information as well as other useful information is to use the cat command on the process slash okay, let me see, cat slash process version. file. Okay. Does this give us? Does this give us more information? Okay. Linux version 6.116 plus Kali AMD 64. Dev at Kali 8684 Linux GCC 14 Debian 14 GNUI ID. Okay. All right. Here you can see that the processor version files are sent the same. I will I'll just use the command, like the easy command, not the cat command. Let's look more like a hacker. So let's put on our hood. Okay. Next one. Okay. The kernel with kernel tuning with 6. Okay. With the right commands, you can tune your kernel, meaning you can change memory allocations. I don't want to do that. Enable networking features and even harden the kernel against outside attacks. Modern Linux kernels use the syscl command to tune kernel operation. All changes you make with this remain in effect only until you reboot the system. To make any changes permanent, you have to edit the configuration file for the... I don't think that's a good idea. Okay, a word of warning. You need to be careful when you use CTL because without your proper knowledge and experience, you can easily make your system unbootable and unusable. Make sure you're considerate what you're doing carefully before making implemented changes. Let's take a look at the contents of CTL now. By now, you should recognize the options we give the commands shown below. Dev, auto close, that. Oh, I forgot to. Okay. All right. So I don't know if this, if there are any like info that I could find here that I would not want to be, out there. So give me 1 second. Yeah, give me 1 second. All right, so this I will probably have to do sudo on this one. I mean, let me see if I can do it without doing sudo. Oh my gosh, yeah, of course, like, let's go down to the end. Okay. All right, let's print all of it. Okay, not bad, it's not bad, it's not bad. So this is everything that we have. Right, probably secure. User max. Man, that's a lot. Oh shoot. No. Let's see. Default. Let me see if they have any info like on my connection. I mean, I still have my connection on like static. So I change it every day. So I don't know. But anyways, we are live. So I'm trying to get hacked live. That's the opposite of this live stream. You know what I'm saying? It's like we're not supposed to be getting hacked. We're supposed to learn about hacking and everything. But it doesn't seem like it has. Well, I will say it doesn't seem like it has any important info. But maybe it is. Maybe it has. Maybe that's not. But there's something to like look more into it. You know what I'm saying? Something to sit down and study more. Like, yeah. Dynamic. Okay. I'm gonna quit out of this, but that was a lot of info. That's a lot of info. Okay. Okay. So it says in the output you should see hundreds of lines of parameters that a Linux administrator can edit to optimize the kernel. There are a few lines here that are useful to you as a hacker. As an example, how you might use 16 look enabling packet forwarding. In the man in the middle attack, the hacker places themselves between communicating hosts to intercept information. Traffic passes through the hacker's system so they can view and possibly alter the communication. One way to achieve this routing is to enable packet forwarding. If you scroll down few pages in the output, or filter for IPv4, since I get up IPv4 such less, you should see the following somewhere in the output. Alright, in the net line, we can actually do that here. Okay, let me move this here and then here's the here. Okay, okay. Alright, so let me just note down that. Alright, in the middle attack. And then in the middle, okay. A hacker can place themselves. I mean, we know that between the communicating hosts to intercept information. Okay. So what they do is, what it does is the traffic passes through hacker system so they can use themselves passively. One can achieve this by enabling the hacker achieves this by enabling gets forwarding. Okay, so we can check if we grab for IPv4 which IPv4 unless IPv4. Okay, so where you can go to permission denied on key, next default stable secrets. Hold on. Hold on. Okay, let's go back to the top. Okay, all right, so the line nets that IPv4 forward equals 0. is the kernel parameter that enables the kernel to forward on the packet it receives. In other words, the packet it receives is sent back out. The default setting is 0, which means that the packet's forwarding is disabled. To enable API forwarding, change the 0 to 1 by entering the following. Ooh. Okay, so the line. Sorry, y'all. I gotta put this down, okay, because that's actually important. I'm gonna practice doing that. IPv4 dot IP forward okay, forward equals 0. Change that 0 to 1 to enable it using this command. System C control -w net, is that right? IPv4 dot IP forward equals 1. Okay. Remember that the system control changes take place at runtime but are lost when the program is rebooted. To make permanent changes to the system control, you need to edit the configuration file. etc/system control config. Let's change the way the kernel handles IP forwarding for man-in-the-middle attacks and make this change permanent. Oh no, I don't want to do that right now. Oh, no sir, I'm good. I am good, sir. But we're gonna learn how it works though, I'm gonna practice later. I'm probably gonna create another VM so I could be, doing these on 2 different VMs. Ooh-wee! It's a lot that you can do with the VM, It's a lot that you can do with the VM. It's really a lot. Okay, so to enable IP forwarding, okay, in the middle attack per minute. So enable IP forwarding, open the etc/system control.config in the text editor, such as leafpad and comment deadline or IP forward. Open. Hold on. I still want to open it though. Don't get me wrong. I still want to open that. Quit. I still want to open the line so that I can see. Okay. So then nano /etc system control.com. One thing that I've realized. Let me see. Okay, there's nothing here. What if we seed into it? CTR. No. Yeah. Locate system C. Yeah. CTL. We want the config. Yeah, readme. Let's see. System CTL. Conf. Okay. System man. Oh, it's under user. It looks like it's under user in this man 5. Oh. Okay, let's look by its by ourselves. Okay, let's go there, and then here we can look. Okay, so you're looking for system CTL. I mean, we could probably have, grab that. Anyways, system log. So it's system ctl.d. Okay, so slash si, 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 60. See. Is there nothing like that? Oh. Oh. How do I list it? Okay. List it. But grab this versus. Yeah, that's what I thought. So we can do nano space t l.d. R syslog. That's system log. That's syslog. That's different, right? That's different from what we're looking for. System. Yeah, that's directory. Directory. It doesn't seem like it's here for me. It doesn't seem like it's here. I might have to look for it elsewhere. It doesn't seem like it's here for me. It might be in another place. Yeah, it might be in another place. Hold on. Let's see though. Let's see what they're saying this. What is that? Okay, so the relevant line is so all you have to do is just remove the comments. Okay. From an operating system hardening perspective, you could use this file to disable ICMP echo request by adding the line. It will cause one to make it more difficult but not impossible for hackers to find your system. After adding the line, you will need to write. Okay. Let's take a note of that. We can make it hard for hackers to access ICMP by adding one to blah 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 net dot IPv4 dot ICMP echo underscore ignore underscore off equals 1. So those, like, basically 1 enables it and 0 disables it. and everything basically. Okay. Okay, so managing kernel modules. All right. So first of all, after adding the line, you need to run the command system TP. Okay, so I forgot about that. After adding adding the line, you need to run the command sysctl -p. All right, so Linux has at least two ways to manage kernel modules. The older way is to use a group of commands built around the insmod suite. Insmod stands for insert module and is intended to deal with modules. The second way, using the modprob command, we will employ little later in this chapter. Here are the lsmod command from the insmod switch to the list installed menu on the kernel. Okay, so let's see what we got on our kernel. Oh. I don't know what any of these modules do, so let me just exit out of it really. Oh, that's the end. Anyways. Alright, so as you can see, the lsmod command lists all the kernel modules as well as information on their size and what other modules may use them. So for instance, the NF netlink module, a message-based protocol for communicating between the kernel and user space, is 16,000 bytes and used by both the NFnetlink log module and the NFSlink queue module. From the insmod suite, we can load or insert a module with insmod and remove a module with rmod, which stands for remove module. These commands are not perfect and may not take into account module dependencies, so using them can leave your kernel unstable or unusable. As a result, modern distributions of Linux have now added the modprob command, which automatically loads dependencies and make loading and removing kernel modules less risky. We'll cover modpod in a moment. First, we see how to get information about our module. Okay, so finding information about our modules with our mod info. Alright, to learn more about any of the kernel modules, we can use the mod info command. The syntax for this command is straightforward. Mod info followed by the name of the module you want to learn about. For example, if you wanted to retrieve basic information on the Bluetooth kernel module you saw when you ran the lsmod command earlier, you can enter the following: mod info Bluetooth. I don't have any Bluetooth, so let's do mod info. Okay, it's I2C SM bus. Okay. Oops. Oopsie. Okay. Um, the bus is protocol extension support. Jean Delvar. Sims bus. Yes. What is this for? Where it has the signature and hash log, and it has a signature key inside near. Big time auto generated. Maybe let's do something like AHCI. Oh my god. AHCI. Alright, so okay. This is a good example. Alright, so AHCI. Oh my gosh, oh, look at me. Oh, what did I do? Oh, what did I do? Whatever, man. Okay, more masks to ignore control. ACI control devices and input. It gives us. It gives us info, but doesn't necessarily tell us what it is. You know, doesn't tell us what it is like that. Maybe I have to look more on it about it, but it doesn't tell us much. As you can see, the mod info comments reveal significant information about the kernel module, which is necessary to use Bluetooth on your system. Note that among many other things, it lists the module dependencies. RFKL, generic and fast dependencies are modules that must be installed for Bluetooth module to function properly. Typically, this is useful information when troubleshooting why a particular hardware device is not working. Besides nothing things like the dependencies, you can get information about version of the module and the version of the kernel the module was developed for, then make sure they match version you are running. Yeah, so that's something you can do as a system administrator, you know, looking at actually why most of your some things is not working on your computer. I know what I'd be doing, but I don't be using. I mean, this is something new that I just learned, so I might start using that in troubleshooting. Adding and removing modules with mod probe. Most newer distribution Linux, including Kali Linux, include mod probe commands for LKM management. To add module to your kernel, you would use the probe. That's the command. That's the command to use it, but I'm not going to remove anything or add anything right now, because you have to understand what modules you are adding on your computer. You know what I'm saying? Like you gotta understand. And I know this is like this for me is I like that. Hold on, do I have any note writing? What's this one? Text editor. Okay, let's see. Text editor. It's not. I know. But okay, it's text editor. Text editor. But remix blue dark apps scalable. Oh, what is that? Okay, sorry. A major advantage of using modprobe instead of insmod is that modprobe understands dependencies, options, and installation and removal procedures, and it takes all of this into account before making changes. Thus, it is easier and safer to add and remove kernel modules with modprobe. Inserting and moving a kernel module. Let's try inserting and removing a test module to help you familiarize yourself with this process. Let's imagine that you're just installed a new video card and you need to install the drivers for it. Remember, drivers for devices are usually installed directly into the kernel to give them the necessary access to function properly. This also makes drivers fertile ground for malicious hackers to install. a rootkit, or other listening device. Let's assume, for demonstration purposes, don't actually run this command, that we want to add a new video driver named Hackers Arise New Video. You can add it to the kernel by entering the following. Yeah, see, I'm not doing that. To test whether the new module loaded properly, you can run the smudge command and print out the message buffer from the kernel, and then filter for video and look for any alerts that will indicate a problem. If there are kernel messages with the word video in them, they will be displayed here. If nothing appears, there are no messages containing that keyword. Then to remove this message module, you can enter the same command path with the R remove slash, which is remove switch. Remember, the loadable kernel modules are convenience to a Linux user slash admin, but they are also a major security weakness to one that professional hackers should be familiar with. As I said before, the LKMs can be the perfect vehicle to get your rootkit into the kernel and wreak havoc. Okay, summary. All right, so we're done with chapter 15. It's not something that we can do right now, but it's something that I will be practicing on my own time, without live, and then maybe in the future I could make a video about it. For now, this is what we're going to do. This is all that we're going to do, and next chapter is going to be chapter 16, which is automating tasks with job scheduling. I hope finally in this one we're gonna start doing some Python programming or whatever. But yeah, guys, so that's it. That will make this a short Thanksgiving live stream. So I want to give my thanks to everyone who have joined me so far. Now I want to give out my thanks to everyone who have subscribed, and for anyone who will and subscribe in the future. Scripting for basic hackers, yes sir. We're going to do chapter 17, which will have Python. Let's go. That's probably gonna be my favorite chapter, and it looks like it's the last chapter. Oh no, we're about to finish the book. Oh, let's go. So we're going to finish this book, and then I will have to do something that shows either a project or anything, or a live stream that shows whatever things I will learn from this book. And after this book, I will try to look into the next book, that kind of like follows these. This is like beginner, right? We're going from beginner to semi-beginner to semi-intermediate to intermediate to semi-intermediate, and that whatever that follows after that is I once watched a video, and then somebody said that you can't really tell a person's level. I mean, you can tell if someone is a beginner, right? But you can't tell if someone is well, they can be advanced, but like they can't be that advanced, because a bunch of tools like in IT, or even in cybersecurity, there's different ways to do things. So I can't say that I am a pro in Python programming. I might know some stuff, or maybe even a lot of stuff, but like not everything. I mean, there are those god programmers or whatever they are. Like those people are just different. Okay, we don't judge them. Only God does, because anything above them is just a god. But that's it for this live stream. It's a short one, but it's a useful one. It was a great useful one. We got some notes. So yeah, well, I will see you guys in another one, and remember, have a good Thanksgiving. Eat a lot so you can enjoy tomorrow and rest.